Hi, everyone. Thanks for coming to my talk late on the last day of this great conference. My name's Adam McElhinney. I'm CEO of a company called Uptake. And today we're going to talk about all things related to fleets and fleet data. I've planned a pretty ambitious talk for 20 minutes, so I may skip through some material. I want to just give a little bit of background about myself so you understand where I'm coming from. I want to start off and just talk about AI and data strategy for fleets in general. I want to talk about why AI is revolutionizing fleets right now, what's changed to make this relevant. I want to talk about what I see are the main use cases for AI for fleets. I'm going to give you guys a checklist that I've used with other companies to help them understand what are good use cases for AI. And then I want to deep dive a little bit into one use case, which is predictive maintenance. And then I want to leave you guys with some concrete recommendations that you guys can take back to your organization. And hopefully we'll also have time for questions. So pretty jam-packed 25 minutes we have planned here. In my night job, I'm a professor, so I love questions, I love interruption, pretty small room. Feel free to chime in at any time. Like I mentioned, my day job, I'm CEO of a company called Uptake. We help customers reduce unplanned downtime. But at night, I'm on the advisory board of the University of Illinois Chicago College of Engineering. I'm on the board of several startups, and I teach computer science and mathematics at Illinois Institute of Technology. I have 19 patents related to machine learning and artificial intelligence, mostly for industrial applications. This is something I'm immensely passionate about and could talk forever about. So I'm going to go ahead and skip that. So I think something that's really interesting, and it's really lost in a lot of the conversations right now, is why AI is becoming so much more salient. There's really three things that have changed in the past 5 years to make AI a much more practical technology than it has been. The technology behind AI, the underlying algorithms, they've actually been around since the 1970s, but for a very long time, they're really just toys or kind of research interests. But there's three things that really made them much more implementable recently. The first is probably the hardest to understand. It was a theoretical advancement in 2017. There's a famous paper that came out of Google called Attention is All You Need that introduced this new algorithm called the transformer. So who's heard of ChatGPT? Assume everyone. The T in GPT is transformer. This was a theoretical advancement that Google invented. Interestingly, none of the folks that authored this original paper are still with Google. They've all left to do their own AI startups, which kind of illustrates how this technology is really becoming commercialized. Second thing that's really changed is the availability of computing horsepower. So something that's unique about these neural network models is the performance of these really scales linearly as a function of the computing power that you throw at it. So historically, older algorithms, once you hit a certain data size and a certain amount of computational power, you'd see really diminishing marginal returns. That's not really the case with these new AI algorithms, and that's why you're hearing about these massive, $500 billion investments in compute that are being applied in ways that we historically haven't. Lastly is the quantity of data that these models are able to ingest. So there's this thing called Common Crawl. It's an open source, freely accessible index of the entire web. Any of you can go download that data right now or part of that data right now. That's what's being used to train a lot of these algorithms. But more and more you're seeing companies sign kind of proprietary data licensing arrangements, like Google famously signed one with Reddit to have exclusive access to all their content for their AI models. So what does this mean for fleets? How should you all be thinking about AI and data sets that you guys have access to and applying it to your fleets? I think as you guys are thinking this through, there's kind of two axes that you should be thinking on. So the first is the impact. And so the way I score this is I like to ask the question, if I could fully automate this task via AI, what would be the impact to my fleet? And a 0 would be no impact, it's totally worthless. And a 10 would be absolutely game-changing. And the second axis I think you should be thinking about is viability. So how realistic is it that I could fully automate this task, using tools and techniques that are commonly available today. So I'm not talking about viability. If you're Google, it can throw $500 billion at something. I'm really scoring this in viability from our perspective of, maybe I have 1,000 vehicles in my fleet. I'm somewhat tech savvy, but I don't have a whole data center of GPUs and a whole team of researchers waiting for me. So a 0 is totally not viable in the real world and unproven, and a 10 would be easily and cheaply available from many vendors for any situation. Those two actions. So I think the most salient use cases for AI for fleet are these, and I'll show you how I score them according to those two axes. So one is routing. Can we optimally route our vehicles to save time, fuel costs, safety, et cetera? Customer service. This is a pretty broad category, but every fleet has a large amount of kind of just updates, like where is this vehicle right now? When is this load scheduled to be delivered? What is the next PM scheduled for my truck? Predictive maintenance. Can I identify what's going to happen or what's going to break on my vehicle before I take unplanned downtime? And like I said, I'm going to deep dive to that one in the tail end of this presentation. Autonomous driving. So if you look at the P&L for a large on-highway trucking company, drivers are typically the second largest expense. Can we fully remove the human from driving? Driver behavior monitoring. This includes cameras. Can we detect bad driving behaviors such as smoking, distracted driving, harsh braking events inside the vehicle and outside the vehicle? Warranty submission. Almost every large fleet I talk to has a 10-person warranty team pushing paperwork around. Are there applications of AI to help automate that? And then inventory and parts management. We're all trying to strike this balance of how much inventory do we hold on the books, do we keep in the warehouse, versus making sure that we have the right part available to get our vehicles back out as quickly as possible. So when I think about applications of AI for fleets, this is kind of how I score them. So I think autonomous driving is right now totally impractical for most of us. So I give it around a 2. But I think that this really has the potential to be totally game-changing. Like I said, at least from a heavy-duty trucking perspective, this is typically the second largest cost of any vehicle or any heavy-duty trucking organization out there. Something that I think is very viable right now, but maybe not that impactful, is customer service. There's a variety of really good tools out there and AI agents that can answer basic queries such as, when is my next oil change for a particular vehicle? But it's really not going to totally upend the operations of your fleet. It's nice to have, but again, it's probably a little bit lower on the impact. What I do in my day job, we're focused on predictive maintenance. I don't think it's as impactful as autonomous driving, but we're pretty commonly seeing fleets operate in low to mid 80% availability. So if predictive maintenance can get them to 90, 95% availability, you're essentially getting more vehicles for free for the cost of the vehicles that you already have. And it's quite viable. We have applications out there and our competitors have applications out there for basically any telematics provider out there. And it's more or less a point and click, turn it on and start realizing the benefits type of situation. So as you guys are thinking about your data strategy and kind of what are some things that you guys might think about implementing AI in your organization, there's this checklist that I would encourage you guys to use. And when I consult with companies on nights and weekends and they I help them plan their AI strategy, this is kind of the sanity check that I go through with them. So first is, can you quantify the value of an initiative? So let's say somebody comes to you and they're like, hey, I have an idea for this AI chatbot that's going to answer questions about where their packages are. First question you want to ask is, okay, how much are we spending on that today? If you don't know or can't figure it out, I don't think it's a good use case for AI. I've seen a lot of these initiatives kind of die on the vine because you can't measure the impact of the AI. To measure the impact of the AI, you got to know where you're at before and then measure that incremental delta. Second is the business value of that initiative material. So somebody comes to us and says, hey, we want an AI chatbot to help us understand where our packages are and let customers know. If we're a $100 million a year company and we're spending $100K on this, do we really care? Is that material? we're starved for attention and time, and a lot of these things, if they're not material enough, they just don't get the resources to get across the finish line. Third is, do you have a lot of input data? So if there's a situation, it may be very, very high value, but it only happens occasionally or very rarely. That's not a great use case for AI. So if you have some highly complicated regulatory situation, maybe it checks the first couple boxes, but if you only do it a couple times a year, AI really needs a lot of data to be successful in automating these types of tasks. This one's a little bit tricky to explain, but do you have or can you create a representative validation data set? So what I mean by this is anytime you develop one of these initiatives, you want to back test this thing before you turn it on. And by back test it, I mean you want to replay and pretend this thing is on and then score how good it is. So let's go back to that example of I want a customer service chatbot that answers where customers' packages are. How can I validate whether or not this thing's successfully answering those questions? A lot of times I could have humans looking at the output of the AI and scoring them as good or bad. There's different ways of doing that, but it's very important that you have some mechanism for validating what good looks like before you launch it. And then last, can a subject matter expert do the behavior you want at a small scale? So I mentioned one of my night jobs is I teach computer science. I teach a machine learning class. As part of that, the graduate students are asked to pick an actual project and implement some machine learning techniques on it. And almost every semester, I'll have some students come to me with some project where they're going to predict the stock market in some form or something like that. And I always tell them, hey, that for me fails that last check mark because it's very debatable whether there's humans in the world that can consistently outpredict the stock market. So I don't think that as a student project you'll be able to implement an AI algorithm that can outpredict the stock market, right? In a fleet context, that could be some type of complicated safety automation or something like that. If there's not somebody, a human, who can show you how to do it, then it's unlikely that you'll be able to train an AI to replicate that. Let's deep dive into one use case, and that's predictive maintenance. So the goal of predictive maintenance is really to identify and alert on failures before they happen so preventative measures can be taken. Many of us are focused on normal PMs right now. That's where we have a schedule set up, typically by the OEM, but many of you, I'm sure, have customized that based on your own experience, where we say either at a number of hours or number of miles, we're going to perform some type of maintenance function. But the goal of predictive maintenance is to actually identify those things using more fine-grained data than just how many miles have elapsed since the last time we swapped out the coolant pump, as an example. Measuring what is actually an out-of-service event is actually very difficult. And under the hood, we have a whole bunch of AI algorithms that just clean up and label out-of-service events. But these component failures, they're often indicated in work order data. They may be labeled as roadside breakdowns, road calls. They may be an engine derate or some other type of limited vehicle operational state. So one approach that's commonly taken, and I'm sure many of you are using Geotab for this today, might be to look at the fault codes that are firing on the truck. The way these fault codes work, it's basically like if this, then that logic that's coded onto the ECUs by the OEM. So has the engine temperature been higher than some threshold for 2 minutes? If so, raise an engine temperature fault code. This is pretty simplistic logic, and there's a couple of challenges that can occur at this. So the first, these fault codes are extremely, extremely noisy. It's not uncommon for us to see on our customer base, like a Class 8 truck, have 300 to 400 fault codes generated per month. I was at our booth yesterday, and 2 women came up to me, and I was showing them our product, and one woman said, well, how is this different than the fault codes that we're already getting off the equipment? The other colleague the other woman turned to her colleague and said, yeah, I have to go Google what those mean. I don't know how to troubleshoot them. I don't know which ones I can ignore. And my maintenance techs just half the time clear them out and send the vehicle back without doing any maintenance anyway. That's not uncommon for us to hear. So a lot of times this results in you missing the true issues that are occurring on the vehicle. The second issue is it can be very difficult to trace these things back to what actually happened to the vehicle. So imagine you have two vehicles. They both have the same fault codes fire. One of them takes an unplanned downtime event. Question is, well, why did one fail with a certain set of fault codes when another one didn't fail with that exact same set of fault codes? We see this all the time. Could be due to which faults occurred, what sequence they occurred in, how long they persisted. It could be due to what type of vehicle it was operating on, or what are the ambient conditions, or how is the vehicle being operated, right? I think all of us intuitively understand if you see a bunch of ABS fault codes fire, if you're in a snowy, difficult, icy situation, that means one thing, and it means something totally different if somebody's driving on Orlando streets on a pretty nice day like today. So Uptake takes a couple different approaches to do predictive maintenance. So one approach is a fault code only approach. And actually with Geotab, we don't actually have to use this approach that often because fortunately Geotab provides extremely high quality signal data coming off the vehicle. But let's go through this example as well. So we'll train machine learning models. We'll pair up the instances of those true failures that come from the maintenance records. And again, I mentioned that actually cleaning up that maintenance and failure data, there's a whole set of machine learning algorithms that we have that just do that, but I won't go into those. And then we pair those with that fault code data, and the machine learning algorithms learn what sequence of fault codes over what duration, combined with what ambient conditions, combined with what make and model of vehicle are actually predictive of failures on that vehicle. You can think of this as like a very complicated recommendation engine, not entirely too dissimilar to what you see in Netflix when you log in and it says, here's recommended movies that you might be interested in. You can somewhat simplistically think of this as like, here's recommended fault codes that we know if these things fire in this sequence, in this combination, under these ambient conditions, you actually need to pay attention to. But I mentioned Geotab. Very strong partner of ours, and Geotab actually provides very, very high quality signal data coming off the asset. So it's one thing to know that the engine overheating light is going on, but it's far better if we can actually see the coolant temperatures and pressures coming off the equipment. And again, we're at a Geotab conference. Geotab is the best at that. I'm not just saying that because we're at a conference. They give us very, very high quality signal data, so we don't have to just look at the faults. We can overlay that continuous sensor reading coming off that equipment and use that to enhance our machine learning algorithms. This allows for much more powerful algorithms and much further time to detect before a failure event. The way to think about this, I mentioned that I would never undertake any AI use case unless a human could kind of look at it and do it at a small scale. You can think of these sensor-based algorithms as a human kind of looking at these, doing some engineering analysis and saying like, okay, I'm starting to see this signal fluctuate combined with this contextual data. I know that that's going to lead to a failure. The goal of this is really to increase lead time. So with earlier detection, we can avoid these failures and unplanned downtime. Sensor data provides significantly more information than faults, which allows us to detect this more in advance, which allows you to react and minimize disruptions, make whatever necessary adjustments, etc. So I have a couple of recommendations I want to leave you guys with as you think about the kind of data strategy for your fleet. So one, make sure that you've identified which metrics your company cares most about. A lot of times I'll talk with a customer and I'll say, hey, we can help you reduce unplanned downtime. And then I'll ask them, like, how do you measure unplanned downtime? And I may get 5 different answers from 5 different people at the company. You really kind of need to standardize on one set of metrics, write them down, make sure you're all kind of measuring it the same way. I actually don't have a very strong opinion on what are the best metrics. I just think it's really important that everyone in the company measure it the same way and work off the same set of definitions. Also, everyone has dirty data. So there's this bad joke that data scientists spend 80% of their time cleaning dirty data and 20% of their time complaining about cleaning dirty data, right? So you don't need perfect data. I understand that this data set, is typically entered by some mechanic covered in grease, operating under very difficult circumstances. So you don't need to have perfect data, but you really should make some minimal investments in data quality scorecards, just looking at things like, okay, Are the Geotab devices turned on? Are they assigned to the right vehicles? Are we capturing maintenance information in our repair system? Are we auditing the maintenance data that's captured in our repair system? We had an example of a customer where there was one technician, he just used the same VMRS code for every single repair that he did. He was required to enter one in, so if you looked at the distribution of VMRS codes per technician, it looked like this one tech was doing only like this one very specific oil related issue, and he was just entering in just really bad data. Again, it doesn't have to be perfect, but like catching really egregious cases like that will really make your life a lot better, no matter what type of data initiative that you're working on. And then third, have a written data strategy. So it's really important, I know it's cliche, we've probably all seen the Wall Street Journal headline, like data is the new oil. I hate cliches like that, but I do think data is increasingly valuable for fleets to differentiate themselves. Ideally, your company has a written business strategy, and ideally you're thinking about data as a horizontal asset that goes across your organization, and you have a written data strategy that's aligned with your company's broader strategy. We are right on time. What questions can I answer for you all about data, AI, predictive maintenance, or anything else?
We've got like 2 PM time for 1 or 2. Last call?
Well, if there are no questions, thank you very much. Please don't hesitate to reach out or connect on LinkedIn. I love talking about data, AI, anything maintenance related. Thank you very much.